Hello and welcome to this video series where I'll be going through the June 2013 Electrons, Waves and Photons paper. Like I've said before, please make sure you pause the video and have a go at the question yourself first before you watch the work solutions, because you'll gain the most from these videos if you do it that way. Okay, so let's get started with question 1. It shows an IV characteristic of a slice of a semiconducting material. Okay, they've plotted the current on the y-axis and the potential difference on the x-axis, and it said for the first part of the question, define resistance. Okay, so let me bring that down. So it's the potential difference across a component divided by the current flowing through it. Okay, I've taken that as a word-for-word definition from the mark scheme. Okay, and like I've said in class, we should be keeping, or we should have, a glossary of all the key terms that we need to know for the exam with the word-for-word definitions for them, so that we can just recall them in the exam questions, because this is a really easy way to pick up marks, because all you've got to do is just recall that definition word for word. Okay, so the second part says show that the resistance of the slice is about 250 ohms when there's a current of 40 milliamps in it. Okay, so we know that resistance is equal to the voltage across a component divided by the current flowing through it. We have the current, but we don't have the voltage. Okay, what we need to do is we need to use the graph to find that. So we go up to 40 milliamps, we read across on the graph, and then we read the voltage, and we can see that that's 10 volts. So now we have all the information to work out the resistance. Okay, it's 10 volts divided by, now the current, be really careful because it's given you the current in milliamps. That is not an SI unit, and this equation relies on SI units. You must put all of the variables with the SI units, and the SI units for current are amps. So 40 milliamps into amps, you divide by 1000, so that's 0.04 amps. Okay, and that's going to give me exactly 250 ohms. This is a question that you can easily see whether you got the right answer or not, because if it's not anywhere near 250 ohms, you know you've done something wrong. Okay, next question. It's showing you now the dimensions of this slice of this semiconductor that they're talking about. Okay, and it's now said calculate the resistivity rho of this semiconducting slice when there's a current of 40 milliamps in it. Okay, and they give you resistivity in your formula booklet. It's just the resistance times the cross-section area divided by the length. Okay, so let's have a look where we get all these values from. So resistance, you might not think they've given it to you, but they have, because they've said what's the resistivity when there's a current of 40 milliamps. Well, you've already worked out the resistance in the last question. That was 250 ohms. Okay, that's what the answer to the last question was. Therefore, we know the resistance is 250 ohms. The cross-sectional area, let me write that up here. That's going to be, if we see that the current is flowing this way, okay, then we know that this is going to be, this bit here is going to be our cross-section area, this bit I've shaded in here. So that's going to be this length, which is 1.2 times 10 to the minus 3 meters. And then now I've got to multiply it by this length along here, which is, they give that to me back here, it's 1.5. So 1.5 times 10 to the minus 2. Okay, let's just write the length down. So the length is going to be this bit along here. That's also 1.5 times 10 to the minus 2 meters. Okay, now we're going to multiply the resistance by the area and then divide by the length. But one of the dimensions for the area is the same as the dimension for the length. So you can see these are going to cancel out in this particular example. So actually all as I have to do is 250 ohms multiplied by 1.2 times 10 to the minus 3. Okay, and then if I plug that into my calculator, I get an answer of 0.3, and that will be in units of ohm meters, which is the units for resistivity. So I can put down here 0.3. Okay, so in this particular example, I multiply for the area. I multiplied this dimension by this dimension to get the cross-section area. But this dimension here happens to be the same one as the length. Therefore, if I'm multiplying by 1.5 times 10 to the minus 2, then dividing by 1.5 times 10 to the minus 2, then those are just going to cancel. So I can actually just write 1.2 times 10 to the minus 3 and multiply by the resistance.